So hello students, I welcome you all to today's new question. The today's question is based on heat transfer. This specific question we are going to solve, and this question was asked in GATE exam in the respective subject heat transfer. So we'll be looking at this question and we'll see how this question can be solved. So the question says a brick wall of 20 centimeter thickness has thermal conductivity 0.7 watt per meter Kelvin. Okay, so whatever the question is saying, we will be doing it correspondingly. Therefore, it is saying wave wall. Okay, so here we are going to solve this, and we have a wall. So let me draw the wall. So let's say this is wall, and the thickness is 20 centimeter. So we prefer to write all the quantities already in SI units, so I write it 0.2 meter. The question says now further, this material, whatever the wall is made up of, this material, the thermal conductivity of the material is 0.7. K is equal to, let me say it K1. So K1 is equal to 0.7 watt per meter Kelvin. Now the question says then an insulation of thermal conductivity of 0.2 watt per meter Kelvin is to be applied on one side of the wall, so the heat transfer through wall reduces by 75%. So now what the question is saying that, let me use the better pen to distinguish the previous case and now whatever the question is saying. So let's say this, before the temperature was here, the temperature was T1 and T2. So now question is saying, let's say this is case 1, and here we'll be doing case 2. Then it is saying that we have a wall with a modification, that is insulation. Here saying an insulation of thermal conductivity of 0.2 watt per meter Kelvin is introduced. Therefore we add insulation. Let's say we don't know the thickness of how much thickness we have introduced, so this is already specified. This is 0.2 meter, and let's say this is X. We have this K1, this K2, and this is the insulation part. Now the question says keeping the temperature difference same in the both case. Okay, so let's say in case 1 we have T1 T2, here it is also T1 and T2, but the temperature difference would be along the this both two wall. Here it was between material 1 only. Now it will be between this material 1 and across material 2. So here we don't need to specify the interface temperature, this temperature. We only had this both boundary temperature. Let's assume that before it was the flux in case 1, let's define it Q. So we can write Q is equal to T1 minus T2. Let assume here T1 is greater than T2, so we can write T1 minus T2 divided by the resistance, which is 0.2 over K, that is 0.7, and area, we don't know the area, so let it be A. Now in case 2, so we can write this flux as Q. Let's define this flux as Q1, and we define the flux of second case as Q2, so we can distinguish it better. So Q2 will be, let me reuse the better pen. Q2 will be, the temperature difference is kept same, so T1 minus T2 upon we have to write whole resistance, this composite wall resistance, so it will be what, R will be equal to this R1 plus this R2. So both here both are in series, so we have to add the both the resistance, that it will be 0.2 over K, 0.7 into A, plus here we don't know the length, so it will be x upon 0.2 into a. Here k2 is specified, so we write that q2 will be t1 minus t2 upon 0.2 upon 0.7 into a plus x over 0.2 into a. Now if we look at the question is saying in this second case, if we apply insulation, the flux reduces by 75%. What is it? It is basically saying that q2 is nothing but 75 reduced percent of q1. q2 is what? 0.25. q1, that is 75% reduced. So if we apply this relation, so it will be t1 minus t2. So let me write it here, t1 minus t2 upon 0.2 upon 0.7 into a plus x over 0.2 a is equal to q1. We have q1 as t1 minus t2 upon 0.2 upon 0.7 a, and this whole quantity we have 0.25 with multiplied. So if I solve this, we can eliminate t1 minus t2 from both the case, and if we cross multiply, we will get here, if we simplify this, 0.2 over 0.7 a multiplied with 0.25 into 0.2 over 0.7 a plus x over 0.2 a. We can eliminate a from the denominator both the side, and we will get 0.2 over 0.7 is equal to 0.25 into 0.2, that is 0.05 over 0.7 plus 0.25 x over 0.2. Now if we solve this this expression, we can deduct the value of x. So that was asked in the question, but we have to be careful that the answer we are going to enter in the CBT mode will be in centimeter. What we will get here, x, it will be in meter, so you have to convert it centimeter by multiply with 100. So you will the answer. Okay, so let me write here the final answer. Final answer, it will be x into 100 centimeter. So whatever we asked here is in centimeter, so you have to answer it accordingly. X here, x will be 0.171 meter. It will be 0.17 meter, and since we have asked to find it in centimeter, so answer will be 0.171 into 100. It will be 17.1 centimeter. So we will confidently enter the answer as 17.1 centimeter. So thank you for your kind attention.